So I'm going to use Adobe Audition here to get some insight into how music, audio, is stored as digital bits and bytes. So I've loaded up a music file. Very nice. And you can see the music here in this form. It's a waveform, and of course we know that sound is a wave, analog sound is a wave because we went to science class. And we can zoom in tighter and tighter on this, and we can see a nice smooth wave. But there does come a point, actually, if we zoom right in, we can see that that nice smooth wave actually is a sequence of dots. So each one of these dots is a sample. They've taken the position of the wave at that moment in time and used that to determine the position of the wave at that moment in time, obviously. So that's really useful. So we can see that lots and lots of dots together gives you a nice smooth wave, and there's enough of them. And talking about enough of them, let's just have a quick glance at some numbers here. So this is 3 minutes 0 seconds 0.12035, and over here is 3 minutes 0 seconds 0.12045. So this is exactly 1/1000th of a second further on. So if I just go and count the dots in here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19-ish. So there's 19 dots in 1/1000th of a second, which is useful to look at because looking down here, bottom right, I can see it's a 192,000 hertz file. So 19, is that right? 19 samples, and this was it 1,000th or 1/10,000th? 1, 2, 3. It's 1/10,000th. Yes, that's right. So 19 times 110 times 10,000 is actually 190 odd thousand dots per second. And that's your sample rate. And just to see the difference, if I open up the same music but recorded at a much lower quality, so just check. I can actually hear the difference, it sounds rubbish. And we can see down the bottom corner down here is 8,000 hertz, and if we zoom in, we can see we've got the dots spaced a lot further apart, don't they? And if I look at the numbers, 328.849 and then 328.85. All right. Yeah, so that's 1/1000th of a second more. And between those two values, we've got 1, 2, 3, 4, 5, 6, 7, 8. And 8,000, 8 times 1,000. Yeah, that's right. So the number of dots is how many samples have been taken to store these. So that's just each one of these is a number stored in a file. Now, while we're here, we'll just talk about bit rate as well. This is an 8-bit file. That means that in terms of the height of these dots, the positions that they can take, obviously there's a scale, a maximum and a minimum, and by being 8-bit, it means that each dot can take one of 256 possible positions from the bottom to the top of the wave. So that's actually not very many, so it means there's quite a big jump from one position to the next, and that affects the quality. So if I now open that other file and just have a quick look, I mean, we can't really see the difference. Well, it does look smoother, doesn't it? But down here we can see it's actually a 32-bit, which means there's millions of positions between minimum and maximum that any dot can take. So it gives a lot more fidelity to the music. So sample rate is how far apart the dots are along the horizontal axis here, and the bit depth, I hope I used the word bit depth earlier. Bit depth is how many positions vertically can be taken by the dot, and that's what creates high quality music.